Okay, let's start lesson 12.1 in your book, page 642, inverse variations. In inverse variations, we're talking about something we already know to start with, direct variations. And if you remember, a direct variation is y equals kx, where some constant value of k. So as y gets bigger, or as x gets bigger, y gets bigger, and both ways. Okay? So, what we're going to talk about today is kind of the opposite of that, the inverse variation. In this formula, x times y is equal to k as long as k is not equal to 0. So what we have here is as x gets bigger, well, y has to get smaller in order for k to stay the same. Okay, so y decreases as x gets bigger, or vice versa. As x gets smaller, y would get bigger. Okay? All right. This is stated as y varies inversely as x. If you remember back when we were doing direct variations, they would state y varies directly as x. Now it's inversely as x. Okay? And it's also sometimes called y is inversely proportional to x. And if you remember direct variations, they would say y is directly proportional to x. Okay, so now it's the word inverse is in there. And the difference is as x increases, y decreases. And there's our formula. Okay, there's a classic case to this. Let's just talk about that right off the bat. The classic case is the case of rate times time equals distance. Okay? So if you think about it for a while, if I want to travel somewhere from point A to point B, it's always 10 miles. And if I go at a very slow rate, it takes me a longer amount of time. So as the rate gets slower and slower, the time has to get bigger and bigger in order to cover the distance. And the same thing is different. As the rate gets bigger and bigger and faster, then my time is cut down smaller and smaller and smaller. And I'm still going the same distance every time. Notice x and y are my rate and my time, and my k is the distance, or constant distance all the time. So let's use the example here. Let's say that we want to go 250 miles. And since we want to go 250 miles, we want to ask, well, what's our rate? Well, let's say rate is 5. Then we want to know how much time will it take us to do that? Well, that's pretty simple calculation. You got t times 5 equals 250. You just divide both sides by 5, and t is equal to 50. Okay? So let's say this is an hour, so it would be 50 hours to go 5 miles per hour. It takes 50 hours to go 250 miles. Okay? So if we were to fill out a chart on that, and I'll just do a simple chart. The more complex one is in your book. All right? So we've got our rate and our time, and we know that at 5 miles per hour, we're going to take 50 hours to go the 250. What happens if we said, well, let's go 15 miles per hour? Well, if you do the calculation and change this number to 15, you're dividing 250 by 15, and when you do that, you get 16.7. Okay? And if you go 25, okay, 25, you get 10. 25t equals 250, divide both sides by 25. So you can see I'm just doing this calculation over and over again, calculating the different values of t. And I'm going to go all the way up to, let's say, 35. And at 35, I get 7.14. And then we'll end it at 50. At 50, I get 5. So that's a small little chart. In the book, they have a lot more points. But if I wanted to graph that, I look at my coordinate, or quadrant 1 of my coordinate plane, and I say that time is the up and down axis, and rate is this other axis, the horizontal axis. And I'm going to tick marks at, let's say, 10 miles per hour each and 10 miles each. Okay? And this is the hours up here, and this is the rate. So let's map out 5 and 50. If this is rate of 5, right there's 5, and my time is 50. My rate is 15, right there in the middle. My time is 16.7. There's 10 and there's 20, so 16.7 is somewhere in the middle. Now it's 25 and 10, right on the dot. 35 and 7, and 50 and 5. So you can see that my chart looks something like this. My graph looks something like that. Okay. Now let's look at another example here. Let's say we're given that x times y is always equal to 90. So that is our standard inverse variation. We're told this is an inverse variation. And what they want to know, what is the value of x when y is equal to 15? Okay? Well, since we know that, let's make our chart, and they want us to graph it. So let's make our chart look like this. X and y down the side. And let's solve that first one. Okay? Let's say we got 15 times x. So I've just substituted the 15 in for where the y was. Excuse me. I haven't done the chart yet. And it equals 90. So I'm going to divide both sides by 15. And I find out that when y is equal to 15, x has got to equal to 6. Because the 90 is constant. Stays the same all the time. Okay? So now, basically, this is just factoring. What are the factors of 90? And if I made a chart, a factoring chart, I not only could do positive numbers, I could do negative numbers. So let's start with negative numbers. Let's just start with 9 and 10. So negative 9 times negative 10 is going to give me 90, positive 90. How about negative 6? We just did it, negative 6 and negative 15. How about negative 3? Negative 30. I'm just arbitrarily picking numbers here. Negative 2, negative 45. I could do negative 1. I'm not going to. I'm going to do 0 just to make it interesting. If x is 0, well, y can't be anything. Because 0 times anything is 0. I'll never get to 90. So this is undefined. Okay. Now we're on the. Let's just go back up the scale. We'll do 2. And 45, we'll do the positive side, same numbers, 3 and 30, and 6 and 15, and finally 9 and 10. And so now we have a nice chart here. Now if we were going to graph that, now all of a sudden we have two sets of numbers to graph. Okay, we've got a set of numbers here that are all positive, so they're going to be up here in this graph. We have another set of numbers, these, they're all negative. They're going to be down here in this quadrant. And when I'm all said and done, you can see it in the book, but my graph, this will be the negative numbers up here, and my positive numbers will look like this. And notice what happened at 0. There is no. This line never touches 0. This line never touches 0. This line never touches 0. There is nothing at 0. It's undefined. Okay?